I'm Victor. I've been working at Swisscom for now 5 years as a data analytics and AI engineer. And today with me...
I'm Pavlos. I'm a senior data scientist. It's a small room. I'm good at shouting. My name is Pavlos, and I'm a senior data scientist at Swisscom. I've been here for a while.
So just out of curiosity, how many of you, by show of hands, have used a chatbot to answer a question or solve some issue? Nice. And how many of you have been happy with how the chatbot actually performed? Nice.
Half an hour.
Nice. So for people who live in Switzerland, have you used Swisscom's chatbot? And happy? Well, not the people who work on it, perhaps. They are a little biased. But yeah, how many of you were happy with the interaction with Swisscom chatbot? Okay, cool. And are there any people in this room that actually prefer to talk to a human agent rather than a chatbot to solve their issues? Interesting. Okay. Okay, that's nice to hear. Parvez and I are part of the conversational AI unit within Swisscom. We're nicknamed Plato, and we aim to revolutionize interactions in order to become customers' favorite choice. And Plato is central at Swisscom when it comes to residential customer care, both on the text and the voice channel. So on the voice channel, when you call the customer care hotline or on 0800 800 800, but also when you send a text message via WhatsApp, SMS, Apple Business Chat, and so on. But the best way to illustrate what we do is to show you a demo of Sam. That's what our chatbot is called, because not a lot of you perhaps are familiar. So let's just imagine a situation where I've been exhibiting some issues with my internet connection, and I would like to know how to solve that. So I want to ask Swisscom's chatbot to help me out with that. And first I get proactively this nice greeting, and Sam starts the conversation, and then it asks me how it can help. Then I try to write my inquiry, but I don't really do a great job at explaining what my problem is. I keep it very generic somehow, so obviously there is not a lot of information so that the bot can help. And therefore, Sam needs to ask me further questions in order to understand the situation and find the root cause and find the best way that it can help me. And then once it has enough information to kind of narrow down to a single solution, it will provide a link and provide an explanation on a site where I can go and check my connection and see the status and see how I can actually solve my problem. So we are the team who is responsible to properly understand the customer intention, to discover the root cause behind a certain observed behavior or outcome of what our customers are getting. And we need to properly disambiguate and clarify what customers mean in order to get to a particular solution, and kind of collect all the information that might be needed further down the road as we go along with the dialogue. And then in the end, obviously, the most important part is to route them to the correct solution so that they don't have to call again, they don't have to contact us again and complain that, well, our proposed solution didn't really work. And there are 3 types of solutions that Sam can offer. One is a completely automated use case where the chatbot can help the customers completely autonomously without involving a human in the loop. And here it can also kind of perform actions on behalf of the customers. Then we have another type where we, as you saw before in the demo, we send some additional information, we answer some questions, or we can send a link where the customer can solve their issues in a more kind of self-service manner. And then obviously a third alternative where maybe the problem is too complex, or maybe we just decided that it would be better for a human to address this issue, and then we kind of route them to a human agent so that they can provide support. In numbers, our impact is as following. So on the textual channel, we have more than 876,000 interactions per year, and we support 4 languages, namely German, English, Italian, and French, and you can see the distribution of which language our customers use on the slide. And out of that, around 20% of the cases are fully automated, so there is no need for a human in the loop. On the voice channel, we are talking about a much, much higher volume of more than 4.8 million interactions per year, and around 3% automation there. But given the huge volume, like in absolute terms, this is still quite a significant offload of the human agent. So it's like quite a significant amount of requests that are fully automated. To get a little more technical and have a look what it takes to actually build such a, and maintain, of course, such a chatbot in production, I want to kind of visualize, but in a simplified way, the main building blocks that we have. So obviously for every product that is in production, we need to have this foundational layer because we need to answer questions such as, well, how do we store the data in a secure way? How do we store the models? What pipelines do we use? We need to have some kind of automated testing, deployment, but also logging, monitoring, alerting, so everything that happens in production as well. All of that is absolutely indispensable. And then, as I mentioned before, we serve customers on many different channels. So some of them are textual, some of them are voice. All of these somehow need to be harmonized for further processing, and that's what the input API does, so that everything is kind of converted into text so that it can be easily processed afterwards. And then we have the centerpiece, which is the dialogue manager. And the dialogue manager is a component whose responsibility is to keep the state of the conversation and decide what is the next best step to take in order to move the conversation in the right direction. And the dialogue manager can use a lot of internal APIs to, I don't know, get the, for example, build a customer profile, or get information about already known outages, or get some billing information about the customer, and so on. And obviously, it uses quite a lot of machine learning models in order to understand what the customer is talking about. And then it connects all of these pieces together and makes a decision on how to respond to the customer's request. So with respect to the machine learning models, we have a plethora of components that perform different tasks, such as intent recognition, entity extraction, machine translation, you name it. We really have quite a lot of things, but also when you have ML models in place, you do need quite a lot of helpers, because, well, training pipelines, data labeling, all of that has to be in place. So this is really quite a significant effort to build all of those things, maintain them, and just keep them running. And wouldn't it be nice if this can somehow magically be replaced by an all-purpose LLM that can do everything out of the box, and the LLM doesn't necessarily even have to be on premise, so it can just be used as a service, and it will simplify our job quite a lot. So our current chatbot implementation approach is a hybrid between ML models and rule-based decision trees. So the classifiers are used to extract all sorts of information from the user input, from the textual input. And then this information is combined together with some syntax rules based on the sentences, and then kind of we have decision trees that decide on where to go next and what the best course of action would be. However, there is a disadvantage to this, as I mentioned already. So developing all of these task-specific classifiers, but also analyzing the data and trying to figure out the rules and how to build and design those decision trees is quite time-consuming, potentially doesn't cover all the cases, so it's not exhaustive. But it obviously does not scale all that well because you have the human in the loop. So yeah, it's not automated, and for sure it cannot be just offered as a service to others who want to build their own chatbot or provide the content for their use cases. And even from a customer experience point of view, there are some limitations. So as you can see here in the first dialogue, we can observe that we don't really provide the flexibility for the customer to digress or change their mind and move on to something else. So there is kind of this need to just follow the predefined steps. But what happens if the customer doesn't really, well, if this dialogue does not fit completely what the customer wanted? Or if the customer changes their mind and says, oh, I solved my problem, let's move on to something else, or I'm done, it's not great to respond to, oh, I did not understand what you mean, can you repeat? And then another case where the bot is really unable to handle multi-intent requests. So if the customer says, I want to achieve A, B, and C, at the moment, we don't really have the kind of memory that is needed in order to solve things step by step. But it's like we probably will detect A, and then just completely ignore B and C and ask, oh, have I helped you? Can you give me some feedback on this one?
As you all know, LLMs have transformed the landscape of chatbot development, and basically we wanted to also at Swisscom jump on this train and benefit from it. So, I mean, thanks to LLM features, we have much more natural dialogues, we have coherent dialogues, and we have context awareness in the dialogue. We offer more flexibility, so we can do chit-chat, we can handle multiple intents, we can digress, come back to the topic, we can handle cancellations. We can basically have a better performance and accuracy in terms of resolving the customer request, while providing a higher scalability, so we can actually generalize across tasks and domains much faster. Let me quickly show you a demo of basically the chatbot we built and are in the process of building with LLM. First, user is doing a small chit-chat. Then user is basically phrasing two requests in the same sentence. So they want to postpone their bill, and they also have an internet issue. Notice that the bot recognizes both requests, and they basically proceed to the first one. They ask for the confirmation, they go on, and afterwards they basically, bot is able to bring the customer to the, help customer on the second request. And while the bot is helping us, basically guiding us through the conversation repair, user is digressing and asking a question about the impact of 5G on their health. Thanks to RAG, we actually answered this question. We bring back the conversation on the second topic, but suddenly user changes their mind and okay, they manage to actually, the problem is fixed, so they don't need us anymore. We handle this cancellation well, and we say, is there something else we can help you with? And out of the blue, apparently there is a really urgent issue with the toaster that is burning. And the chatbot is able to provide some useful information while abiding by the prompt instructions, so remaining in the basically realm of being a customer care agent only. So maybe in a nutshell, what is the purpose of the LLM, the way we use it? As Victor explained you, we rely on a dialogue engine. which is handling our business use cases. In our terminology, we call them flows. And the LLM is kind of serving as a bridge between the dialogue engine and the customer. As you saw, it's going to replace all our machine learning components to find the intent of the customer somehow. And the main purpose of the LLM is actually to predict the next action of the dialogue engine. Let me explain you in detail what our prompt is made of. So first of all, we have a description of the task. So we tell the LLM, analyze the conversation and generate a list of actions. We then provide the description of our business use cases, our flows, and additional information that is related to the business use case. We call them slots. So, for example, we have a flow which encapsulates all the administrative requests related to SIM and eSIM. Anything related to activating, transferring, blocking, unblocking of a SIM or eSIM is basically handled in this flow, and we tell the LLM, this is the slot you need to fill, and these are the potential values you can fill the slot with. We then provide basically the conversation history and the list of currently active flows that we have on the stack to the LLM, so to present as well as possible the context of the information to the LLM. We have a RAG service in Swisscom, so we actually query the RAG service with the query of the customer, and we get back the answer, and we also inject this answer into our LLM prompt. We explain for what type of reasons a transfer to a human is allowed. For example, when they explicitly ask for agent, don't start doing it. We're going to put guardrails around this post. Call back or not understood. So basically, we tell for these type of questions, you can basically predict an action of transfer to agent. And last but not least, basically we describe the possible actions that LLM is able to take. So if they can start a flow, they can cancel a flow, it can set a slot, ask for clarification question, decide that the answer from RAG was the best answer, do a chit chat, or do a human handoff. And we also give some instructions basically to the LLM how to use these actions. Maybe quickly, what is our current focus? Basically, we have RAG on one side and we have flows on the other side, and sometimes we have some duplicated or at some points conflicting information between RAG and flows, and basically we have we trigger RAG too often. So we just are working to curate our knowledge base. At the same time, RAG is not able to take actions. Flows are able to call APIs and talk to different, let's say, internal components that we have in Swisscom to resolve the requests of the customer. For example, to postpone the deadline of the payment, we need to call certain APIs. So in these cases, RAG should not get triggered, and we just have to make sure that we have a proper, let's say, trigger ratio between the two. And very important that the bot tone should be consistent, so that we, across different interactions, we manage to basically keep the customer engaged and not confuse customer. We are also rethinking a bit our evaluation methodology. So evaluating the entire dialogue is a bit basically different than before. Thanks to LLM features, we have all this flexibility, and there is also the non-deterministic nature of LLM. So we cannot directly reuse our previous production conversation. We are rethinking of building new data sets, and also more, let's say, introducing new metrics that can correctly evaluate the responses of LLMs. Which at the same time we are able also to track the metrics that are important for us, so track the efficiency of the process automation and as well the user experience and satisfaction. Another important point is that again, because of the inherent nature, inherent non-discriminative, non-deterministic, the nature of LLMs, a small variation in the input might result to a different output. And we would like to keep results consistent, so somehow to instill the trust and reliability for the customer. So this, for us, is important as well. We are if I may have just one more minute for this slide. Maybe pros of using the LLMs, as I showed you, basically the conversations are much more flexible. We can support multiple intents and interruptions. The speed of the development is much faster and yeah, more natural conversations. We, as well with the RAG, we have this possibility to extend have an extensible knowledge base and extend over the knowledge that we, the queries that we need to handle with knowledge. On the downside, of course, is the cost of working with LLMs. In our case, we have some experiments with GPT-4. Of course, as a mitigation strategy, we can have, let's say, an on-prem model or fine-tune them or etc. So we are working also on such mitigation strategies. Another point is the high inference time. At this point in time, we also have workloads both on AWS and Azure. So there is also, let's say, we can definitely improve on our inference time right now, and we are working on this. We also have very limited, but we do have hallucinations in the output of the RAG. And as another point is this consistency, so having the consistent resolution to avoid, because of a small difference of basically writing the request, the resolution might change, and this is not really ideal for us. Thanks a lot for your attention, and please shoot if you have any questions.